Tonight I want to take you somewhere extraordinary, yet deeply peaceful. A place where the very fabric of reality whispers its secrets through equations and experiments, where the universe has drawn an invisible line that nothing can cross. We're going to explore together why the speed of light isn't just fast, it's the ultimate cosmic speed limit, written into the very mathematics of existence itself. As you settle in tonight, wherever you are in the world, whether it's late evening in New York, past midnight in London, or perhaps early morning in Tokyo, I wonder what time shows on your clock right now. Time, as we'll discover tonight, isn't quite what it seems, especially when we approach that mysterious boundary of light speed. If these gentle explorations of the cosmos help you drift into peaceful sleep, perhaps you'd like to join me for more of these journeys. A simple like or subscribe means we can continue wandering through these cosmic mysteries together, night after night, exploring the quiet wonders that surround us all. It's a question that might sound strange at first, something you could easily dismiss as just another rule from a physics textbook. Why can't we go faster than light? It seems almost arbitrary, doesn't it? Like a cosmic traffic law with no apparent reason behind it. But the more we look at it, the more quietly intriguing it becomes. What if this speed limit wasn't just a dry equation in a textbook, but a quiet doorway into how the universe really works? What if the mathematics that keeps us from breaking the light barrier is actually our gentle invitation to understand reality in a way that is both profound and deeply, mysteriously beautiful? Tonight we're going to explore this together, you and I, not with alarm or anxiety about what we cannot do, but with wonder about what this limitation reveals. The math might sound terrifying at first, and perhaps that word catches your attention, but I promise you, by the end of our journey tonight, you'll see it's not terrifying at all. It's protective. It's elegant. It's the universe's way of keeping everything in harmony, including us. Right now, as you lie there listening to my voice, light from your screen or from the stars outside your window is traveling at exactly 289,792,458 meters per second. It never speeds up. It never slows down in the vacuum of space. Every photon in the universe, whether it left a distant galaxy billions of years ago or just emerged from your bedside lamp a fraction of a second ago, obeys this same, unwavering rule. And we're about to understand why. Let's begin by imagining ourselves floating in the vast darkness of space. Not the frightening kind of darkness, but the peaceful kind, like being wrapped in the softest black velvet, punctuated by the gentle glow of distant stars. Each point of light you see has sent its photons on a journey that might have taken thousands, millions, even billions of years to reach us. And every single one of those photons traveled at exactly the same speed. No faster, no slower, just that one, perfect, universal constant. We are tiny, and yet somehow tuned into the patterns of the universe. Our minds, these collections of atoms that learn to think, have discovered something remarkable about the cosmos we inhabit. We've found that buried in the mathematics of motion, hidden in the very equations that describe how anything moves through space and time, there's a barrier. Not a wall exactly, but something more subtle. Something woven into the fabric of space-time itself. Think about how we normally experience speed in our everyday lives. When you're walking slowly through a garden, you might move at 3 miles per hour. If you get in your car and drive on the highway, you might travel at 60 or 70 miles per hour. An airplane might carry you at 500 miles per hour. Each increase in speed feels natural, expected. You might think that if we just keep pushing harder, keep adding more energy, we could keep going faster and faster forever. But the universe has other plans. The story of why light speed cannot be broken begins over a century ago, with a young patent clerk in Switzerland who dared to think differently about space and time. Albert Einstein wasn't trying to limit our cosmic ambitions. He was simply trying to understand why light behaves so strangely. You see, scientists had noticed something peculiar. No matter how fast you were moving when you measured the speed of light, you always got the same answer. If you were standing still, light moved past you at 209,792,458 meters per second. If you were racing toward the light source at half the speed of light, you'd expect to measure the light coming toward you faster, wouldn't you? But no, still exactly 299,792,458 meters per second. Even if you were somehow racing away from the light at tremendous speed, when you measured the light catching up to you, same answer. Always the same, perfectly constant. This constancy of light speed might seem like a small detail, a quirk of nature, but Einstein realized it was telling us something profound about reality itself. If the speed of light is the same for everyone, no matter how they're moving, then something else has to give. And what gives, what bends and stretches to accommodate this cosmic truth, is space and time themselves. Here's where the mathematics begins to whisper its secrets. When Einstein worked through the equations, and we won't burden ourselves with the complex symbols tonight, just the beautiful ideas they represent, he discovered something extraordinary. As you approach the speed of light, the universe begins to play tricks that aren't tricks at all, but fundamental features of reality. First, there's what happens to time. We think of time as universal, ticking away at the same rate everywhere. 1 second for you is 1 second for me. But that's only true when we're moving slowly relative to each other. As you accelerate toward light speed, something remarkable happens. Time begins to slow down for you relative to someone standing still. Not in your perception, you would feel completely normal, but in the actual flow of time itself, your watch would tick slower, your thoughts would process slower, your very atoms would vibrate slower. All of this happens according to a very specific mathematical relationship, one that approaches infinity as you approach light speed. Let me paint you a picture of what this means. Imagine you could somehow build a spacecraft capable of traveling at 99.9999% the speed of light. From your perspective inside the ship, everything would feel normal. You'd eat breakfast, read a book, maybe take a nap. But while you experienced what felt like a day, Earth would experience years passing. The math tells us that at that speed, one of your days would equal about 2 years on Earth. Push a little closer to light speed, say 99%, and one of your days becomes 20 years on Earth. The closer you get to that ultimate barrier, the more extreme this time dilation becomes. This isn't science fiction. We see this happening every single day. The GPS satellites orbiting our planet have to account for this time dilation in their calculations. Even at their relatively modest speeds, their clocks run at a slightly different rate than clocks on Earth's surface. Without correcting for this relativistic effect, GPS would accumulate errors of about 10 kilometers per day. The mathematics that keeps you from getting lost on your drive to work is the same mathematics that prevents anything from breaking the light speed barrier. But time dilation is only part of the story. There's also what happens to space itself. As you accelerate toward light speed, distances in the direction of your motion begin to contract. What might be a journey of 4 light years to the nearest star at rest becomes shorter and shorter as your speed increases. At 99.9999% light speed, that 4 light year journey contracts to just a few light days from your perspective. The universe literally squeezes itself along your direction of motion. And then there's the most insurmountable barrier of all. What happens to mass and energy? This is where the mathematics becomes not terrifying, but absolutely forbidding in its finality. As you accelerate any object with mass, its relativistic mass increases. The faster you go, the heavier you become from the perspective of the universe trying to push you. At half the speed of light, your mass increases by about 15%. At 90% light speed, your mass more than doubles. At 99.990% light speed, your mass becomes more than 200 times what it was at rest. This, increasing mass, means it takes more and more energy to achieve each incremental increase in speed. The energy required doesn't just increase linearly or even exponentially. It approaches infinity as you approach light speed. To accelerate just a single gram of matter, less than the weight of a paperclip, to the speed of a light would require infinite energy. More energy than exists in all the stars, in all the galaxies, in the entire observable universe. The mathematics doesn't just discourage faster than light travel, it makes it literally impossible for anything with mass. Let's pause here for a moment and really feel the weight of what we're discovering together. The universe hasn't arbitrarily decided that 296,792,558 meters per second is fast enough. Instead, this speed limit emerges from the very geometry of space-time. It's not a rule imposed upon reality, it is reality. The speed of light is the speed at which cause and effect propagate through the universe. It's the speed at which space and time themselves are woven together. Think about ripples on a pond. When you drop a stone into still water, waves spread out in perfect circles. The speed of those waves is determined by the properties of the water itself, its density, its surface tension, its depth. You can't make the ripples travel faster by dropping a heavier stone or throwing it harder. The medium itself determines the speed. In the same way, the speed of light is determined by the properties of space-time itself. It's the natural speed at which disturbances propagate through the fabric of reality. This is why light, having no mass, naturally travels at this maximum speed. Photons don't have to accelerate to light speed. They're born at that speed and die at that speed, never experiencing anything else. They are pure energy, pure information, surfing along at the maximum rate the universe allows. For a photon, the journey from a distant star to your eye takes no time at all from its perspective. Time dilation is so extreme at light speed that the entire history of the universe passes in what would be a single, timeless instant for the photon. We're about halfway through our journey now, and perhaps you're feeling the gentle weight of these ideas settling over you like a comfortable blanket. The mathematics that seemed terrifying at first is revealing itself to be something else entirely. It's the universe's way of maintaining causality, of ensuring that effects always follow causes, that information can't travel backward in time, that the story of the cosmos unfolds in an orderly if mysterious way. Scientists have tested these ideas in countless ways, and every experiment confirms what the mathematics predicts. They've accelerated particles in massive colliders, pushing them to 19,99991% the speed of light. Just as the equations predict these particles become hundreds of times heavier, their internal clocks slow to a crawl, and the energy required to push them even slightly faster becomes astronomical. We've observed cosmic ray particles born in distant stellar explosions, arriving at Earth with energies that dwarf anything we can create in our laboratories. Yet even these, the most energetic particles in the universe, obey the speed limit. There are muons, subatomic particles created when cosmic rays strike our upper atmosphere. These particles have very short lifespans. They should decay long before reaching Earth's surface. But because they're traveling so close to light speed, time dilation allows them to survive the journey. We can detect them at sea level, gentle proof that the mathematics isn't just theoretical, it's happening all around us, all the time, in the silent rain of particles from space. Some scientists have wondered whether there might be loopholes. Perhaps they thought we could find ways to travel faster than light without actually accelerating to that speed. This has led to speculation about things like wormholes, shortcuts through space-time that might connect distant regions of the universe, or the Alcubierre drive, a theoretical way of warping space so that you could arrive at a distant destination faster than light, could travel through normal space without ever locally exceeding light speed yourself. These ideas remain in the realm of speculation, requiring forms of matter and energy we've never observed, perhaps forms that cannot exist. But even if such exotic methods were possible, they wouldn't really break the light speed barrier. They would be ways of circumventing it, of finding cosmic shortcuts that respect the fundamental limit while achieving the practical goal of rapid travel. The mathematics still holds, the barrier remains. Perhaps the universe prefers this arrangement. Maybe there is a deeper pattern we do not yet see. Some scientists wonder if the light speed limit is what allows the universe to exist at all in its current form. Without it, causality would break down. The past could influence the future in paradoxical loops. The stable, orderly cosmos we observe, with its reliable laws and predictable patterns, might be impossible. The speed limit isn't a restriction, it's a foundation. Think about what this means for our place in the universe. We are bound by the same laws that govern the stars, the galaxies, the vast cosmic web of matter and energy that stretches across billions of light years. We cannot break these laws, but we are part of them. We are made of atoms that obey relativistic mechanics, our thoughts carried by electrical signals that propagate at speeds ultimately limited by the speed of light. Even in our smallness, we reflect these same laws. We are not separate from the cosmos. We are expressions of its deepest principles. There's something deeply peaceful about accepting limits, not as defeats, but as the boundaries that give shape to existence. A river flows because its banks contain it. Music has beauty because notes have specific frequencies, not infinite variations. and perhaps consciousness itself, this mysterious ability we have to observe and understand the universe, exists because information cannot travel infinitely fast. The light speed limit creates the possibility of separate locations, distinct moments, individual observers. Without it, everything might collapse into an undifferentiated whole. We come back again and again to the same question. Why this specific speed? Why 299,792,458 meters per second and not something else? The answer takes us even deeper into the nature of reality. This speed emerges from two fundamental properties of empty space, its electric permittivity and magnetic permeability. These properties determine how electric and magnetic fields behave in a vacuum. Light, being an electromagnetic wave, naturally travels at the speed determined by these properties. But why do space have these specific properties? Here we reach the edge of current understanding. Perhaps in other universes, if they exist, these constants have different values, and light travels at different speeds. Perhaps our universe has these values because only such values allow for the complexity we observe. Atoms, molecules, stars, planets, life, consciousness. We don't know. The mathematics describes what is, but the why remains a mystery, a gentle invitation to keep wondering. In another quiet corner of research, scientists study what happens at the quantum level when particles approach light speed. The equations of quantum field theory, which describe the smallest scales of reality, naturally incorporate the light speed limit. Virtual particles, those fleeting fluctuations in the quantum vacuum, respect this limit. The uncertainty principle, which allows particles to briefly borrow energy from the vacuum, still cannot violate the ultimate speed barrier. Even in the fuzzy, probabilistic world of quantum mechanics, the speed of light stands firm. Somewhere in a lab, late at night, faint signals reveal the signatures of particles accelerated to tremendous speeds. Scientists ponder possibilities that stretch the imagination. What if there were particles that always travel faster than light? Tachyons, they're called in theory. The mathematics allows for their existence in a certain sense, but they would have imaginary mass and would travel backward in time from our perspective. No such particles have ever been observed. The universe seems to prefer keeping its speed limit intact. Telescopes collect pale light that has traveled for ages, carrying information about distant galaxies retreating from us as space itself expands. Interestingly, these galaxies can appear to recede faster than light, but this isn't because they're moving through space at such speeds. Space itself is expanding, carrying them away. The galaxies remain at rest in their local space, respecting the speed limit, while the cosmic fabric stretches between us. Even the expansion of the universe finds a way to honor the fundamental barrier while achieving cosmic scale effects. It is possible, though not yet proven, that understanding why light speed cannot be exceeded might lead us to deeper truths about reality. Some researchers have wondered whether space and time themselves emerge from something more fundamental, and the speed of light is a consequence of this deeper structure. Others propose that the limit is related to information theory, that there's a maximum rate at which information can be processed by the universe, and this manifests as the speed of light. What does it mean that our minds can imagine traveling faster than light when the universe forbids it? We can write stories about it, dream about it, create elaborate fantasies of instantaneous travel between stars. Yet the cosmos gently but firmly says no. What does it say about us? That we can describe a universe we barely see, that we can understand limits we'll never transcend. Perhaps this is the beauty of consciousness. We can know about boundaries even from within them. There's something profound about breathing, isn't it? Each breath you take right now involves countless atoms moving at various speeds, all far below the speed of light. The oxygen molecules drift into your lungs at a few hundred meters per second. The electrical signals telling your diaphragm to contract travel along nerves at maybe 100 meters per second. Everything in your body, every process keeping you alive, operates in the slow zone, the realm where relativity's effects are negligible. You exist in the gentle part of the universe, where time flows steadily and space maintains its familiar dimensions. Time passing feels uniform to us because we all travel through space-time at nearly the same speed. We're all on Earth together, rotating at the same rate, orbiting the sun at the same speed, drifting through the galaxy as one. The differences in our velocities are so tiny compared to light speed that we experience synchronized time, we age together, we experience moments together, we share a common now. This is only possible because of the light speed limit. Without it, there would be no universal agreement on what now means. When you look at the stars tonight, if you choose to look, remember that you're seeing them as they were, not as they are. The light speed limit means we always observe the universe's past. That star might be 4 years ago, that one 400 years ago, that fuzzy galaxy 4 million years ago. We live surrounded by history, bathed in ancient light. No matter how strange the universe becomes in our equations, here you are, breathing, resting, held by gravity, held by the quiet laws that never stop working. The mathematics might describe something that sounds like a prison, a cosmic speed trap we can never escape. But consider this, without the light speed limit, would stars shine the way they do? The fusion reactions in stellar cores depend on the precise balance of forces, all of which respect relativistic limits. Would planets form? Would chemistry work the way it does? Would DNA be possible? The very mathematics that keeps us from the stars might be what allows us to exist to wonder about them in the first place. Perhaps the questions themselves are enough for tonight. The question of why we cannot break the light barrier. The question of what it means that such a barrier exists. The question of whether accepting limits is actually a form of freedom. Freedom from paradox, from causality violations, from a universe too chaotic to support conscious observers. Maybe it is enough just to feel the wonder of not fully knowing, of living in a cosmos with firm rules that still leave room for endless discovery. As we drift toward the end of our journey tonight, let's revisit what we've discovered together. We started with what seemed like an arbitrary limit. Nothing can travel faster than light. We found that this limit emerges from the very structure of space-time, from the way space and time are unified into a single fabric. We saw how the mathematics, far from being terrifying, is actually elegant and protective, maintaining the order that allows the universe to function. We explored how mass increases toward infinity as we approach light speed, how time dilates and space contracts, how the energy required to accelerate becomes insurmountable. We discovered that these aren't punishments for trying to go too fast, but natural consequences of living in a universe where space and time are interwoven, where the speed of light is the speed of causality itself. We've seen how this limit is tested and confirmed daily, from GPS satellites to cosmic ray muons, from particle accelerators to distant galaxies. Every observation, every experiment, confirms what Einstein's equations predicted over a century ago. The universe really does have an ultimate speed limit, and that limit is woven into everything we observe. The pacing of our thoughts has slowed now, hasn't it? The concepts that might have seemed sharp and challenging at first have softened into gentle wonders. The mathematics hasn't changed. It remains as absolute as ever, but our relationship to it has transformed. We see it now not as a barrier, but as its architecture, the invisible structure that holds reality together. In the silence between atoms, in the gaps between heartbeats, the laws of physics continue their quiet work. Photons stream at their constant ultimate speed. Time dilates imperceptibly, even for the slow movements of our daily lives. Space maintains its structure, refusing to let anything tear through it faster than light permits. In the hush between stars, vast distances remain vast, protecting each stellar system in its own bubble of causality, its own local story unfolding at its own pace. Somewhere in the universe right now, a photon that left a distant galaxy when Earth was young is just arriving at a telescope, carrying information about a cosmos billions of years gone. Somewhere else, particles in an accelerator are pushing against the relativistic barrier, gaining mass instead of speed as enormous energies pour into them. Somewhere, perhaps, civilizations we'll never meet are discovering these same limits, working through the same equations, feeling the same mix of frustration and wonder at what the universe allows and what it forbids. The phenomenon we've talked about tonight is still unfolding. Light is still racing through the vacuum at its unvarying speed. The mathematics is still constraining and shaping every movement, every interaction, every cause and effect in the cosmos. You remain part of this quiet universe, wrapped in its laws, carried by its mysteries. Your very atoms respect the speed limit. Your thoughts propagate within its bounds. Your dreams unfold in a space-time shaped by these fundamental constraints. What if the real gift of the light speed barrier isn't about traveling to distant stars, but about understanding our place in the cosmic order? We've learned that we're not separate from the universe's laws, but expressions of them. We've discovered that limits can be beautiful, that mathematics can be poetry, that even barriers can be doorways to deeper understanding. The same equations that keep us from exceeding light speed also reveal the true nature of space, time, mass, and energy. They show us how the universe is put together at its most fundamental level. As you lie there tonight, perhaps growing sleepy, remember that you're experiencing time at your own particular rate, determined by your motion through space-time. While you rest, relatively motionless on Earth's surface, you're actually traveling through time at nearly the speed of light, not through space, but through the time dimension of space-time. We're all time travelers, moving into the future at 1 second per second, our personal clocks synchronized by our shared velocity through the cosmos. The terrifying math we began with has transformed, hasn't it? It's become something else, a lullaby of logic, a gentle reminder that we live in an ordered universe. The equations that seem to trap us have shown us freedom within structure. The barrier that appeared to limit us has revealed itself as the foundation that makes everything else possible. Without the light speed limit, there would be no stable atoms, no chemistry, no biology, no consciousness to contemplate the very equations that describe it all. Perhaps tomorrow, or in 1,000 years, we'll discover something new about why light speed cannot be exceeded. Perhaps we'll find deeper principles from which this speed limit emerges. Perhaps we'll understand why the constants of nature have the values they do. Or perhaps this will remain forever a beautiful mystery, a gentle reminder that the universe doesn't owe us all its secrets, that some truths are for wondering about rather than knowing completely. In the quiet depths of space, photons continue their eternal journeys at the one speed they know. They carry no mass, experience no time, travel the only way they can, at the maximum rate the universe permits. They are pure pattern, pure information, pure energy manifesting as electromagnetic waves rippling through the vacuum. Every photon that has ever existed has traveled at exactly the same speed, will always travel at that speed, cannot know any other way of being. And perhaps that's the final lesson for tonight. The universe has its ways, its deep patterns and unbreakable rules. We can study them, marvel at them, build our understanding around them, but ultimately we must accept them. The mathematics that prevents us from breaking the light speed barrier is the same mathematics that allows us to exist, to think, to wonder about our place in the cosmic story. It's not terrifying at all. It's the gentle framework within which all possibilities exist. The stars continue their slow movements across the sky, their light taking years, centuries, millennia to reach us. Galaxies drift apart as space expands between them. Particles dance within their relativistic limits, and you, made of star stuff governed by the same laws that rule the cosmos, prepare to drift into sleep. Your thoughts slow, your breathing deepens, your consciousness begins its nightly journey into dreams where perhaps the speed of light doesn't matter, where imagination can travel instantly anywhere it wishes. But even in sleep, you remain part of this mathematically constrained, beautifully ordered universe. Your atoms continue their quantum dances, respecting the speed limit in every interaction. Your neurons maintain their electrical patterns, signals propagating at speeds far below the ultimate barrier. Your heart beats in time, pumping blood that knows nothing of relativity but obeys it nonetheless. You are safe within the universe's rules, held by laws that never sleep, never vary, never fail. Consider one last thought as you drift towards sleep. The light speed limit means that every star you see is isolated in its own region of space, unable to instantly affect distant neighbors. This isolation allows for diversity, for different stellar systems to evolve independently, for countless experiments in planetary formation and perhaps life. The universe's speed limit creates countless separate stages where different stories can unfold. Earth is one such stage, protected by distance and the speed of light from whatever dramas play out around other stars. We are quarantined by physics itself, given room to develop, to grow, to become whatever we're meant to become. The same mathematics that keeps us from the stars also keeps the stars from us, at least until we're ready, if we ever are. The light speed barrier isn't a wall, it's a membrane, allowing information to flow slowly enough that cause and effect remain local. that stories can unfold at their own pace, that consciousness can emerge in pockets of space and time without being overwhelmed by instant information from everywhere at once. And as you drift into sleep, you remain part of this quiet universe, wrapped in its laws, carried by its mysteries gently, peacefully into the night. The mathematics watches over you, not terrifying but protective, maintaining the cosmic order that allows for sweet dreams and eventual awakening. The speed of light remains constant, the equations remain true, and you remain a precious pattern of matter and energy, thinking and dreaming within the gentle constraints of space-time. Tomorrow the sun will rise, its light taking 8 minutes to reach you, just as the physics demands. The stars will still be distant, the equations will still hold, and the universe will continue its patient unfolding at speeds that never exceed that fundamental limit. But for now, rest. Let the mathematics fade into the background hum of existence. Let the speed of light be what it has always been, not a barrier to break, but a constant to rely on, a truth that helps define the very fabric of the reality where you safely, peacefully, perfectly belong. End.